Good morning, friends. Today we will be discussing about Hive. So far we have spoken about HDFS, MapReduce, scoop import, scoop export, etc. And before getting into the next topic, let's review how the conventional data warehouse will be implemented and how it will be implemented using big data ecosystem. Okay. The conventional data warehousing looks like this. Let me go to the full screen and go to the slide mode. I have 1 minute. This is not the one. File, open recent, more. Introduction. Not this one. Open recent, more. Actually, I have animated these slides. I'm not sure why it is not showing up. Let me check. Let me check real quick. Okay. So now I'm going to slide mode. So if you see the conventional data warehouse, or even not only data warehouse, the data integration framework will look like this. Typically, they will have source systems, a middle layer where the data is being processed, and the visualization layer. Take any data integration projects, these are the things which you will have. The source systems, the middle layer which will actually process the data, and the downstream systems, it could be visualization using typical reporting tools such as business objects, Cognos, etc. Or it could be for other purposes. For example, companies like companies like New York Stock Exchange and all those things, whatever transactions happened, they will publish the feeds after processing the data in the middle layer. They will publish the feeds which will be used from the downstream by the downstream applications. It could be anything. One of the applications is BI or visualization. Okay, but you can at the higher level you can actually categorize into three: the source systems, which are typically disparate; the middle layer where the processing happens; and the target systems where the processed data has to be ported into visualization or feeds, etc. So typically the source systems can be OLTP, so the mission critical transactional systems such as banking applications, retail stores, point of sales, e-commerce platforms, market basket, checkout applications. All those things are transactional based applications. Typically they will be in a relational database, or some of them are still in mainframes. And then still a lot of companies use mainframes for heavy volume real-time reliable transactions. So other source for data will be, especially for very large enterprises, is closed mainframe systems. And then third-party external applications where you need to get the feeds. For example, if you want to get credit score, you have to get into agreement with the credit agencies, and they will be sending credit scores using some unique identifier between the company who is trying to get the credit scores from external sources and the company which is providing the credit scores. So those are typically XML. So you will get data in the XML format or comma separated or JSON in the recent days. And also in some cases we can use REST APIs also. For example, if you want to get Twitter feeds for downstream analytics in our enterprise, or Facebook feeds, you have to use REST APIs to get the data, and data will be returned in the form of JSON or whatever standard they follow. So these are the categories from which you will get the data: the OLTP relational databases, the closed systems such as mainframes, the external applications such as XML files or REST APIs, data using REST APIs, etc. And then in the middle, you will have the data processing layer. For enterprises, typically it is called as enterprise data warehouse. And as part of the enterprise data warehouse, there is a component called ODS, operational data store. And then you have data warehouse. So why do we need to have two systems here, ODS and data warehouse? So I will give you a couple of use cases of ODS, or a couple of reasons to use ODS instead of directly loading data from source systems into data warehouse. So why ODS is, for example, if you are familiar with the data modeling principles, the OLTP systems will have normalized data models where you will create parent table, child table relationships between multiple tables, and then when some transactions happen, multiple tables will be updated in OLTP. But when it comes to data warehouse, which is used for reporting purposes, the reports are typically the trends. So in this case, in OLTP, it's real-time transaction. When I get into a POS, point of sale for a retail firm, I will have few dozens of items in my basket, and then I have to check out and pay the money and go out. So it's for that moment I have to complete the transaction as a user. But as an executive for a retail firm, if someone wants to see the trend, he has to aggregate the transactions done by the individuals like me, like you, so that he can actually get the trend over time, how much revenue is being generated by his retail stores over time. If you want to see the trends, you have to aggregate the data which is stored in multiple tables in the OLTP system. So if you start generating those reports in the OLTP system, you will be hurting the purpose of the OLTP system. Your transactions for the individuals will start taking more time, and also your database will become unstable, because the queries which are required to generate these reports will be very expensive. Okay, especially when you are trying to deal with heavy volumes of data. For that reason, we use a downstream system such as data warehouse, and we try to get data from OLTP to these systems. And here, if you start storing the data in the same format as the transaction systems, again your reports will become very slow. It works, but it will be very slow. For that reason, instead of using normalized data models, so instead of using normalization, creating parent key and foreign key relationship in a third normal form or Boyce chord normal form, we use different modeling for data warehouse, which is called as dimensional modeling. Okay, so in the dimensional modeling, you will define dimensions, fact tables, and you will create data models for related tables using this snowflake schema or star schema. You have to review the data warehousing terminology to understand this thoroughly. If you are already from data warehousing background, you will be connected to this very quickly. As this is not the data warehousing class, I will only use the buzzwords, and you have to explore it further. But the main idea is the model in the data warehouse has to be dimensional model, not the Boyce chord normal form or 3NF, third normal form. So in this case, if you have 10 tables in OLTP, in data warehouse you will have few tables, 2 or 3 tables versus 10 tables in OLTP. So the data model will be completely different from the source systems. And also, as part of the data warehouse, for a given enterprise, we might have to get from multiple sources to finally generate the report. For example, if you think about very large retail stores, the point of sale systems are still mainframes. Okay, and it will only have the transactional data, it will have the customer ID and the transactional data and few other information in mainframes to make it as fast as possible. But the actual data about the customer might be in OLTP system. If you want to get the address of the customer, phone number, email ID, etc., they might not be available in the mainframe systems, but they might be available in the OLTP system. And if you want to generate the reports based on user behavior, so which age group are buying what, you might have to get data from this OLTP system, the mainframe system, and then you have to process and then generate the reports of it. So you can use the enterprise data warehouse, get the data from these source systems into data warehouse and start generating the reports. So that is the purpose of data warehouse and the source systems. Now, what is the purpose of ODSC here? So let's say the executive told his IT team that I want to see the trend of the sales by region. So if you think about US is divided into 4 regions or more, probably, I'm not 100% sure, but let's take the hypothetical case that it is divided into 4 regions, and he wants to see how each region is performing for his company. Okay, for AT&T, I think it's 33 regions. Again, the definition of region might change based on the client you are working with. The executive want to see the trends for each region, how they are evolving over a period of time. That is the requirement, and we have to get the data from OLTP systems, probably closed mainframe systems, and also from external apps. And we started developing the code, developing the report. Okay, but if you want to troubleshoot whether the report generated is correct or not, then it will be a nightmare. You cannot easily get into the source systems and start looking into the issue. There will be a lot of bureaucracy involved. People will not let others to come into the mainframe systems, and also even if they let, these people who are responsible to generate the report might not be knowledgeable enough in the mainframes. So troubleshooting the issues can become tedious. There are multiple use cases for ODS, but I am saying covering one of the scenario why ODS is required. The answer is to troubleshoot the issues for your reports. Instead of going to the mainframes or instead of going to the source system directly, we will maintain the golden copy of all the source data in the ODS. So all the data will be first copied without transformation or with minimal transformations, such as adding audit columns, and store the data into ODS. Okay, so it will maintain the golden copy of the source data. So if there is any issue in the data warehouse, it will be easy to troubleshoot the issues only by going to ODS. As long as the framework between these systems into ODS, which does not have many transformations, you will not find many issues once you develop the data integration framework between the two. The complexity of transformations is between the ODS and data warehouse. That's where most of the issues happen in the enterprise data warehouse world. Okay, so that is the purpose of ODS or operational data store. Venkat was asking the same thing. Yes, ODS stands for operational data store. So these are the things which you will use in the scope of EDW or even for any data integration platform, data integration projects, not just EDW. Sometimes the terms might be a little bit different. Okay, so now we have to get the data from the source systems into ODS as well as EDW. Hence, we have to develop the data integration platform, and the data integration platform can be batch ETL, or you might have to get the data in real time also. Okay, so that's where from all the source systems data has to go through the data integration layer, and from data integration layer data might go to ODS, and then from ODS again it might go to ETL layer and go to the data warehouse. But when the data goes from source systems to ODS through this ETL layer, there will be very minimal transformation. Typically, we will use audit columns on top of the columns we have on the source system, and also tables we cannot define the primary key foreign key relationships, because there are other reasons which I don't want to get into. So you don't find all the relationships between the tables for several reasons. One is performance reason, to load the data as quickly as possible. We disable primary key foreign key, or we don't create primary key foreign key relationships in ODS or operational data store. And from operational data store, again it has to go to the data integration layer. Here we will actually perform lot of transformations to convert the normalized data model into dimensional model to have the processed data in the data warehouse. So this is the typical way of implementing the data warehouse. From here, you will connect the reporting layer such as business objects, Cognos, etc. To generate the reports. Reports can be for two reasons: to see the trends, and also it will help them in decision support. Okay. So now, what are the disadvantages of this before getting into how we will be addressing those challenges in EDW? The disadvantages are, typically ODS will be maintained in traditional RDBMS such as Oracle, MySQL, etc. And typically Oracle will be the one which will be used for most of the enterprises. For hardcore IBM customers, it will be DB2. For hardcore Microsoft customers, it will be SQL Server. Okay, and then data warehouse will be typically implemented using Teradata or Power BI. There are some tools from the Microsoft also. I don't remember. For Oracle, they might use Exadata. They might propose Exadata for data warehouse type of systems. So here you will use appliances which will come with the data warehousing capabilities. Here you will use traditional RDBMS, where you have to set up, where we have to get the servers, and then install OS, install Oracle database, and set up the database. And then for data integration, we use tools like Informatica, Talent, Data Stage, etc. Okay, and if you have to get data in real time, we use tools like Golden Gate, Shareplex, etc. to get data from OLTP systems into ODS. From mainframes, again Golden Gate can be used to get the data from mainframes also. So depending upon the type of load, the data integration tools will change. Typically we use either ETL tools or real-time change data capture tools such as Golden Gate or Shareplex. Okay, and from typically real-time loads will only implemented from source systems into ODS. We never port data from the source systems into data warehouse in real time. That is not a very efficient way of dealing the data integration. But the major challenge is you are using heterogeneous platforms. Means here you are using one type of servers, here you are using appliances, and for ETL or real time you need to get different type of hardware, software, etc. And all of these appliances and all of these tools need to have enterprise class hardware, which is expensive, and also they come up with hefty licensing charges, very expensive to implement a simple reporting, even a simple report using this architecture. Okay, so there is some question, so let me take this. Where does the Hadoop comes here exactly, and what are the pros? That's what. First let us understand the challenges, then we will actually get into the how Hadoop addresses that, and what is the purpose of the scoop which we have already learned, and what is the role of the new tools which we will be learning going forward. Okay, so the main challenge is heterogeneous hardware, and also expensive hardware, and also expensive software. So okay, and then if you want to implement the same thing with Hadoop, the source system does not change, you need to have the source system, and then you have uniform hardware. You have same type of hardware for all the nodes in the cluster, which you will be using, and you can use commodity hardware also, and all of them will have the same operating system, all of them will have similar memory, similar storage capacity, they will be connected using the similar network. So using this Hadoop cluster, we will create both the databases, ODS and EDW, and they are logical databases, they are not physical. You will understand what that logical physical means. All the traditional databases are physical in nature, whereas Hadoop databases are logical in nature. Internally, we are using HDFS for both ODS and EDW to store the data. And to perform the ETL, we should use Hadoop-based tools such as Spark, Hive, Pig, etc. Even if you are using tools like Talend or Informatica, they internally use Hive to process the data. So the actual processing happens using using Hadoop-based tools such as Hive or Spark only. So now, if you think about it, almost everything, the ETL, EDW, ODS are on same hardware, same software, which is open source. Hardware is commodity hardware. You don't need to worry about expensive solutions such as RAID, etc. And as it is uniform, the maintenance costs also will go down significantly once the system is matured enough. Okay, but for real time, most of the tools are proprietary to the existing technology vendors, and they will not open up that easily. To get proper support for tools like Golden Gate, SharePlex, or any mainframes based tools such as SyncSort to get the data from mainframes, you might have to use those tools. You cannot avoid that. But those tools can be deployed on the similar hardware which you are using for the for Hadoop. Okay, and then traditionally the reporting layer, it's changing very fast. Hadoop is not very efficient to use it for reporting. If you go back to the previous picture, so you can so the data warehouse and ODS, which are more traditional in nature, are very friendly for reporting purposes. So you have the support for partitions, indexing, and all those things, and your reports you can actually get the reports in interactive fashion. Okay, but whereas here, I will come back to your question, Mohan. I didn't read the question. I will come back to you. Let me finish this. So the reporting database here is a lightweight reporting database where it will only store the final data which will be used for the reporting purposes after the aggregations at different levels, etc. So traditionally using Hive, which is a database on top of Hadoop, is not good for interactive reporting because Hive is very slow. It is not very good for interactive reporting. So we used to create a reporting database, and then from reporting database we used to provide the visualization. Okay. Now, what is the role of Scoop here, which is already covered? Scoop is meant for getting the data from OLTP and also into HDFS, and also store the data from HDFS into reporting layer. So once the data is processed, you can use Scoop export again to load the data into the reporting database. But when you use tools like Spark, when you try to connect your reporting layer using Spark connectors, you can directly connect to Hadoop cluster. You don't need to go to reporting database. As Spark is in memory, the reporting will be faster, and we will see. You will understand practically when we talk about Spark from the next class. Okay. So typically in this layer, either we will use Hive or Pig or Spark, which is tightly coupled with Hadoop to process the data. So going forward, we will be talking about processing the data. So Scoop will be used to get the data from OLTP systems, but we need to get the data from the other systems also. So Scoop is not the solution for it. And also in some of the cases, even from OLTP system, we will not be using Scoop. For example, let's take the example of the major retail store like Walmart. Okay, they actually store the data in a database called Informix, and they don't want any external forces, external applications directly get data from their systems. They don't want to do that. So what they do, They actually, even though it's a traditional RDBMS database Informix, and Scoop can actually connect to it and get the data, still what they do is source teams will actually take the ownership of providing data to you. So they use their own tools and generate delimited data and give it to you, and from there you have to load into Hadoop. So even though Scoop is available to connect to the source relational databases, it need not be used in all the cases, because if someone uses Scoop without proper knowledge, if he increase number of mappers abnormally, then it will establish too many connections to the source database, and it can cause significant issues for the source databases, which can be risky for the companies like Walmart. Hence, they will never let people to connect to the databases from external applications and get the data from. So again, we need to design the data integration platform considering all these challenges. So don't assume that Scoop should be used to get the data. First, you have to understand what kind of sources you want, from where you want to get the data, and based on that, you have to come up with the data integration platform addressing all the challenges which might encounter. So you have to do proper planning when you try to introduce the Hadoop in the company, and when you want to do the POC. If you try to do the POC with Scoop and later if you realize that that Scoop should not be used, then you will be wasting time unnecessarily. So first you need to understand these challenges even before starting the POC. You have to plan it properly. So let me take the question from Mohan. So can you please repeat about limitation of Hadoop for real time? I think I have answered that question. If you try, for the reporting purposes, if you want to get the reports in interactive fashion. Interactive fashion means once we get into the reporting layer, when we actually change the dimensions, data has to be, the visualization has to be refreshed very fast, and that could not happen using databases like Hive. And when it comes to integrating data into Hadoop in real time, yeah, so I'm talking about that only. When you try to get the data into Hadoop in real time, there is no Hadoop based tool to get the data in real time. You have to use traditional tools such as Golden Gate, Saplex, etc. And if you think about it, typically the OLTP is Oracle database. Even if someone want to build a open source system to actually use the internal features of Oracle to read the transaction logs such as redo log or commit log, etc., the tool which is being developed has to pay the loyalty to those companies. They have to come into the agreement. If they don't come into the agreement, if there are any issues in the tool, the actual database vendors such as Oracle will not provide the support, and then your project will be in jeopardy. For that reason, we typically don't use open source tools for real-time integration. Instead, we have to use the industry standard proprietary tools only, because getting data in real time is a major challenge from most of these mission critical systems such as OLTP and closed mainframes. There, open source might not be a good idea to go. There are some tools like which can replace Golden Gate in open source, but it's very risky to consider those things. Okay, I hope that answered your question. So, and then Venkat have asked which ETL tool using in general for Hadoop projects currently. So, almost all the ETL tools support almost all the ETL tools support big data. So they have big data connectors, and they can actually get data into big data, and also they can process the data in big data. Okay, so so the point here is, even though, so take the example of Informatica. If you are familiar with Informatica, Informatica provides two features. One is a rapid development environment, okay, where you can actually design your mappings and then deploy it. Okay, it will actually translate your ETL requirement. Uh, um, it will let you implement your ETL requirement very fast using the rapid development environment, such as which is RDE in short, such as Power Designer in Power Center in Informatica. Okay, once you develop that, so on top of RDE, Informatica also provides this Informatica server. Okay, so you will be paying license for both the components, RDE as well as the Informatica server. Informatica server is nothing but a software which can understand your mapping, which is developed using rapid development environment or RDE, translate into Informatica proprietary code, and then it will use the hardware on which Informatica is deployed to process the data. It works very well with the traditional EDW, where you don't want to use source systems to perform the transformations or the target system to perform the transformations. Instead, the middle layer, such as Informatica, takes the responsibility, or it will take care of the most of the work to perform the ETL before loading into the database. Now, when it comes to dealing with heavy volumes of data, where Hadoop plays a vital role, if you use Informatica server to process the data, then Informatica server will become a bottleneck. Okay, hence lot of people are not actually going with the licensing licensed tools such as Hive, such as Informatica, because if you try to get big data connector with Informatica, you have to pay the premium to the existing Informatica license. So you will end up paying for the things which you don't want to use. For Informatica server, you will not use. If you use Informatica big data connector, and if you want to leverage Hadoop, you will ask Informatica to use Hadoop to process the data. You will not use Informatica server to process the data. So there is a concept of switching between Informatica server and Hadoop to process the data. You will typically leverage Hadoop to process the data. So you end up paying hefty licensing for Informatica server, which you will never use. So that's the reason why a lot of companies are very skeptical about embracing these ETL tools. Even though they provide RDE, they are very expensive, and you are paying the cost for which you will never use, especially while processing data in Hadoop. That's why a lot of companies using Python as ETL tool and developing their own custom solutions rather than using the enterprise level ETL tools such as Informatica, DataStage, or Talent. Okay, I hope that answers your question. Actually, I have given a lot more information than what you have asked. There are many tools which can work with Hadoop, but no one is embracing that easily because of whatever I have explained just now. So the next question is, how much does the client save on money and resources when they migrate from current EDW to Hadoop based EDW? So that's not a very easy question to answer. Okay, and typically you will face this question most of the times, but it's not easy to answer, especially when you try to talk to the clients. They not only talk on money, they also talk about other aspects. So first thing they will do is, once you do the POC, once you say that okay, this is working in Hadoop, let's move to Hadoop. The first thing what the company will do is, they will try to create the new applications in Hadoop rather than moving the existing ones. Okay, when they try to create, when you try to compare the same report, the same project, deploying in the traditional systems which you already have the company, and the new system which you are trying to bring in, one of the challenge you will face is the sponsor will expect to deliver faster than the already existing system. which is highly unlikely because Hadoop is new, you just created the POC. If it takes only 2 days or 3 days or 1 week for the new report to be deployed in the existing system, it might take 3 months, 4 months, or even 6 months. Some cases even 1 year for Hadoop. So it's very tough to convince the sponsor who is not very technical in those scenarios. That being said, when you want to compare, there are certain areas which you can actually get very reliable information. For example, Teradata appliance. On top of the development and deployment overhead, Teradata appliance will cost you $125,000 approximately. This is 2 years back comparison. As of now, it might have changed significantly, but at that time, for each terabyte data, you will end up paying $125,000 every year to Teradata company. Okay, but when you use Hadoop cluster, for each terabyte of data, you hardly spend $15,000, even when you use very high-end commodity hardware. So the difference in the cost for the infrastructure is significantly lower when it comes to Hadoop. So that's one comparison which I have come across. But when in the bigger picture, you have to take count the other stuff also, and the development timeline might be with Hadoop might be more compared to traditional data warehouses. Eventually, initially it will be expensive, but once you start developing your custom tools, once you build that expertise, over time the cost will come down significantly. Okay, and then Mohan, in reporting the database, how will they deal with detailed reports if only summary tables are exported to reporting DB? So that's what typically details can be at different level. Let's stop here. There are too many questions coming in here. You have to understand all the tools, and then only you will be able to come up with the solution dealing with all these things. To answer your question directly, you can use HBase as a layer to redirect to the details for your reports. Okay, starting from higher granularity, if you want to see the details at the actual raw data, the raw data can be exposed using HBase type of tools, where you can actually redirect. So your application should be smart enough to connect to the NoSQL database and start getting this detailed information. Okay. Again, let's don't get into that. When a company does POC, generally how many node clusters they may. Okay, yeah, this is a valid question. Typically, we start with 9 node cluster, and then eventually we will add more depending upon the requirement. In some cases, some POCs might not be able to be delivered in 9 node cluster, but typically it will be 9 node cluster. So Lakshmi Narayan is asking, in a nutshell, can I say like this: transformations or data cleaning or any mapper or reducer logic what we are developing in ETL tools can be replaced by Python or Scala with Spark? Yes, you are exactly right. Not only, yeah, you are exactly right. These transformations or data cleansing can be on structured data, and also you can deal with unstructured data using Python or Scala with Spark. Okay. So that's it about a little bit primer about big data, an use case using traditional tools and big data ecosystem. You need to build the skills on the buzzwords I have used, such as the data modeling and all those things. And then you will be able to face the questions wherever you face with more confidence. Okay, and on top of that, you need to have practical knowledge on all the tools which you are exploring. Okay, a very good discussion and very good questions. Thank you that you are actually asking those things. It will make it more interesting. Okay. So now let's go on to again. Let me recap here. So in this architecture, whatever we have covered so far, which is Scoop, is to get data from OLTP databases into Hadoop. For most of the cases, there are exceptions. We might not use in all the scenarios. We might not use Scoop in all the scenarios to extract data from relational databases. I have explained the scenarios earlier, so I don't want to get into those details. Once the data is processed, if you want to port the data to reporting layer, then again you might have to use Scoop export to move the data back to reporting database. Okay, and now if you think about Scoop, okay, Scoop is just a utility. You have to develop an application around it to get data from the source systems into Hadoop in a reliable fashion, and then you have to explore the other tools like Hive, Pig or Spark to actually process the data. So as part of the course, I will be covering Hive and Spark. I will not be covering Pig. With Spark, Pig will become completely irrelevant very soon. Okay, Pig is a clumsy language, and whatever benefits you get using Pig can be achieved with Spark also, and Spark will become the de facto standard for scripting purposes. And once we learn Spark, I will have at least 30 minutes to 45 minutes session to compare the Hadoop ecosystem with Spark and why Spark is getting a lot of traction. Okay. So now let's move on to the Hive. So you got the data from Scoop into HDFS, and the data is structured data. So when we try to process the structured data, typically if you are using a Hadoop ecosystem, the Hadoop core components to process the data is MapReduce. So you have to develop the MapReduce programs to process the data, such as data cleansing, transformations, etc. But even to get a count from a table, from any table, by simple grouping, it will take 200 lines, 300 lines code. If you want to do it for in generic fashion to deal with all kinds of file formats, it might even go up. The amount of coding you need to do will go up significantly, and to cover all the exceptions which you might encounter and all, the project will be a nightmare. It will take even a simple report few months to if you start using Hadoop MapReduce. For that reason, they have come up with tools such as Hive and Pig, where you, instead of writing code in Java, you can write code in developer-friendly languages such as SQL or scripting using Pig, and you can start processing the data. That's where the Hive comes into picture. Especially when it comes to structured data, Hive provides three features. One is, let me open the presentation on Hive. So all the details which I am discussing here will be furnished on the website for Hive. Okay, so don't worry about it. That I'm not sharing this PPT. Okay, so when it comes to Hive, it has three main components. One is, as a developer, you need to understand three different areas. One is DDL, like any traditional RDBMS, creating the tables, creating the databases, etc. Second one is, you don't have transactions, and the DML is not as sophisticated in traditional databases. For DML, there are only two types of commands: load and insert. Okay, so you need to understand those two commands in detail, and you need to understand the differences between the two. And then third one is the querying. Okay, so querying is the major portion of processing the data, and to load the data we use load commands and insert commands, and to create the tables we use create table commands. Okay, before getting into those details, let us understand the architecture of Hive. So this is the architecture of Hive. Okay, you have Hive binaries which will be deployed on the gateway node. So if you go to the lab, I am going into the CloudX lab and Ambari. So lab credentials, Ambari. Copy password to clipboard. Training 8634 is the username and this is the password. Okay, and here if you look into the Hive, sorry, I think yeah, if you look into the Hive, there is Hive clients which is installed on all the nodes in the cluster, and then you have Hive server, Hive metastore, and web hcat server. No need to worry about web hcat server here. The main important things are Hive server and Hive metastore. Okay, and on top of that, another important component is client. So whatever node we decide to be a client, which is gateway node, should have the Hive binaries. So that's where this Hive binaries comes into picture. It's nothing but jar files which provides an engine to compile your SQL type of Hive queries into MapReduce programs, Java based MapReduce programs, and submit as a MapReduce job. It uses the same way as Scoop, and the way we have run the Hadoop jar command earlier, it will actually submit the job in the similar manner. So first, the Hive binaries will actually compile the SQL type of query into a MapReduce program using Java-based APIs. They are nothing but Java-based programs, and those Java-based programs will be compiled into a jar file, and that jar file will be submitted on the cluster as a MapReduce job when you actually write a query. So to store the data, it uses HDFS, and to process the data, it uses ER. So it's tightly coupled with MapReduce. And then you have something called Hive metastore in a traditional RDBMS. So what is this metastore? So if you go to the terminal, clear, now I am logging into the cluster. Okay, now we are in the cluster. If you launch Hive, so if you have Cloudera Quick Start VM or single node lab single node lab on AWS, you will have access to MySQL database in which the Hive metastore is stored. You can actually get in there and you can also see the tables. Okay. Anyway, here I will not be showing that. You can watch my videos to understand how to do that. It is not very significant for the development purpose, but you should know what is this metadata is. For that, I am connecting to my database training 8634. Show tables. Okay. So there is a very important command, describe formatted. Describe formatted, very important. If you understand the output of this command, you will master Hive very fast. Okay, describe formatted and the table name. You can see, to begin with, it has the column names. So before actually getting into that, first thing you need to look into is location. Okay, so here is the location for this table. What is this location? This is nothing but a HDFS location. So here I am actually opening another tab, logging into the lab. Okay, now running Hadoop FS ls paste. Okay, so this is optional, you can remove if you want. and then the directory which is written, so the path which is written in the location, okay, and hit enter. So you can see that there are files in this location. So this table is pointing to this location. So location is the place where the data is stored, and this is stored in HDFS. Okay, so it is using HDFS for storage. On top of that, if you look into the data is comma separated, and there are 2 columns. So when I create the table, I specified the delimiter. If it is comma, the delimiter will be comma. If it is some other character, the delimiter will be that character. Okay. And on top of that, I have given column names also. Department ID, department name when I created the table. Whether Scoop have created or we created manually. So these are the column names which are created. Okay. And then there are other details such as what is the database name, and what is the input format, output format for the files, etc. And all this information is called as metadata. Okay, and this metadata needs to be used to when the query is when the Hive binaries actually perform the syntax check whether your query is correct or not. When let's say you didn't give the correct column name, so it has to read the metadata of the table name of the table to check whether the column names are correct or not. It will be as part of the syntax and semantics checks while compiling the query to MapReduce. So before generating the MapReduce job or while generating the MapReduce job, this data will come handy, and it will use this data to actually create a MapReduce application for the query you are trying to run, and for that all this metadata is required. So if Hive stores this metadata in HDFS, HDFS is not very friendly for interactive purposes unless you have used additional tools such as HBase or Spark, etc. You cannot get data very quickly in a reliable fashion from HDFS. For that reason, to perform the syntax checks, as it has to be completed as fast as possible, Hive uses traditional RDBMS for Hive Metastore. So that's where this comes into picture. So it uses HDFS for regular data, yarn, MapReduce plus yarn in the latest version of Hadoop to process the data. You can point to Classic also if you are using only Classic. And then RDBMS to store the metadata of the data. So data will be in HDFS and metadata will be in Metastore. Okay, so data storage, HDFS, the data processing, MapReduce plus yarn, and Metastore for RDBMS for Hive Metastore. So when you actually submit the query for the compiling purposes, it uses the RDBMS, the data that is stored in the RDBMS database. You can point to MySQL or Postgres or Oracle. All these databases are supported. Then it will use that information to create a Java file using MapReduce APIs. That Java code will be compiled into jar file, and that jar file will be submitted as a MapReduce job. So here I will demonstrate that. Now let me see the tables here. There are many tables, and here let me preview the data. Select star from orders limit 10. So this is the simple query to actually preview the data. Here let us say I want to get an insight about how many orders are completed, how many orders are closed, how many orders are pending payment, etc. So there is a question from Mohan. I will come back to that once I complete this. So if I run this query, select order state. So if you just want to get the column names, you can say describe orders and hit enter. So there are these 4 columns: order ID, order date, order customer ID, and order status. So I want to get count by order status, comma, count of 1 from orders group by order status. okay, and hit enter. Now you can see this is the Hotmarks cluster, so it is using test engine. So let me disable test engine and run this query again. So let me set Hive execution engine equal to MR. So if you are preparing for Cloudera certification using this lab, make sure you set Hive execution engine to MR when you try to run Hive queries. Even with test it works, you don't need to worry much about it. But if you want to understand the logging information which is emitted, which might help at the time of taking the certification, it is better to use execution engine to be in sync with the Cloudera certification. Okay, and now I am running the query. So now you see that using MR, it is actually displaying the information in a different manner. So whatever I have explained here is the first implementation of Hive. Now, as you have seen, Hive works in test context. It can work in Spark context also. So you can run Hive queries bypassing MapReduce using test or much more efficient tools such as Spark. Okay. So this is the result we got, and you can see it has actually submitted a MapReduce job. You can go to this URL to get the details about the job, and internally it will actually compile into a jar file. Like Scoop, it does not give the details about what are the classes it has generated and what is the jar file it is trying to compile. But if you try to hack, you will get those details, but it's not that important. As long as you understand that when you try to run Hive queries in a MapReduce engine, it execute in the form of MapReduce jobs, that is more than enough. Okay, and if you see, for this simple query, it took 20 seconds to process 172,000 rows on a multi-node cluster, which is not very efficient for interactive reporting. That's why in the earlier implementations of data warehouse, we have the reporting database layer. So now let me take the questions from, there are a couple of questions. Mohan have asked which DB is used as Hive Metastore. So for most of the clients, I have seen MySQL or Oracle. Those two are the most used databases. So most of the techie savvy companies which don't want to spend money on licensing, they go with open source databases like MySQL and some implementations with Postgres also. The second, and most of the enterprises where they have unlimited licenses with companies like Oracle, and most of the companies have Oracle only for mission critical databases, and they use Oracle also quite a bit. And then Gopi's question, he asked me in private, how does Hive links to HBase? I mean, where does the HBase DB comes into picture after processing in Hive? The same question is used, the same question, there is similar question from Mohan. Yes, you can actually create an external table in Hive connecting to HBase, and you can use Hive-based tables to perform the batch processing. HBase is primarily for real-time operations. If you want to perform some batch processing on top of the data which is in HBase, you can write Hive queries or MapReduce jobs to query the data from HBase and process that. HBase is out of context. If you have further questions on this, we will take it towards the end of the class. So are the Hive tables always logical and physical? Yes, you are right. Hive tables are always logical, and the database is always in HDFS. That's another difference between traditional RDBMSs and Hive. Hive decouples the structure and the data completely. Okay, so you can actually create structures using the tools of your choice on the data you have in HDFS. Okay, using a concept called data frames in Spark, you can create the structure on the fly. So you don't need to actually have a predefined structure on the tables. Using a rigid tool, using one or two tools such as Hive, you can come up with your own framework if you want. So it gives a lot of flexibility by making it logical. Hive does not store anything on the any data apart from HDFS. Okay, so this is this is the overview about Hive query, and how to get the information about the metadata I have covered, and the formatted command also. So now, before getting into the actual details about Hive, the create table command and all those things, few things you need to understand is how to connect to Hive, and what are different options you have. That knowledge is very important, especially if you want to develop a framework around it. Again, Hive queries cannot be a standalone application. You have to integrate as part of some other tool as a wrapper around it. It could be shell scripting, it could be Scala in Spark, it could be it could be Java programming language or anything else, or it could be traditional ETL tools like Informatica, Talent, etc. So before getting into that, Lakshmi Narayan is asking another question: Hive can be dealt with structured, unstructured, and semi-structured data, right? No, that is wrong. Hive is only to define structures for the structured data. You cannot deal with unstructured data very easily with Hive. Pig can take care of that up to some extent, and Spark also can take care up to some extent. Otherwise, you have to write extensive programs to perform that. So Hive is basically a query language, right? No, Hive is not just a query language. It has HiveQL is major part of so the querying language is major part of Hive. On top of that, it has features to create the tables and also to actually store the data into Hive. Why we have to distinguish these things are, there are other tools such as Impala, Spark, even Tez. Okay, they use Hive Metastore and also Hive DDL commands to create the tables. But to query the data, to process the data, they use their own frameworks. Okay, even Pig can be connected to Hive, and you can process data using Pig scripting. So Hive is not just a query language, but it is the query language is major portion of it. Okay, so now let's start with how to start Hive and how to troubleshoot the issues before actually getting into the create table commands and all those things. Okay, so far we are using this command called Hive, and we are actually launching Hive, and we are running the queries. So if you want to use Python or shell scripts to actually submit Hive queries, you cannot launch Hive and run and come out of it very easily. You have to little bit complicated programs for that. So to address that issue, there are other flags in Hive such as Hive-E and Hive-S. So first let us see what is Hive-E. So if you want to run a query or few queries in one shot and get the results redirected to some other file, you can use this Hive-E. So in this case, I want to run the same query which I ran earlier and save the output to a file. Okay, that is my requirement. So I can say use training 8634 semicolon. So I can have multiple commands here, and then select. Let me copy paste the query. Okay, group by order status. Okay, and then I want to redirect to Hive output.txt and hit enter. So now you can use this type of commands as part of your shell scripts without launching Hive, executing it and exiting out from it as part of the script. You can simply use Hive-E and invoke the query and get the output redirected to wherever you want. You can run create table command also if you want to store the data back to Hive. so you can perform all these things. Okay, now it is done. We can review what is there in the Hive output.txt. You get only data. So in case of exceptions, if you want to generate a log for it, you can run the same query. Here we are trying to redirect standard out. You can say one redirect to Hive output. One represents standard out in Linux or Unix, and 2 represents standard error. And you can say Hive output dot log. And let's say I want to use execution engine as MR. Set Hive dot execution engine equal to MR and hit enter. Now you can see that you are not getting the this report here because it is being redirected into Hive output.log. So all this information which is displayed here is actually standard error. Only data is coming as standard out. So that is the feature of the Hive-e command, where the actual output of the queries will come into standard out, and other logging information comes as standard error. And to redirect standard out, you use this one. To redirect standard error, you use this one. So these type of features are relevant even for if you want to use Python, and you have to use these type of features while developing the stand-in out tools such as shell scripting or Python, etc. Now you can actually look into Hive output also, Hive output.log, to see what is there in that file. See, you have all the MapReduce related output here, but the data is not here. Data will be in the data Hive output.log. As I have shown you already, I will not show you again now. Okay, that is about Hive-e. Okay, now if you want to write 10 queries as part of one script, Hive-e is not very good. Hive-e is to just execute one query and a few associated commands, or probably couple of queries and associated commands. So associated commands here are these ones, and the query is this one. Okay. Now if you want to run tens of queries in one shot, one way to deal with it is by using Hive-f. It will take a file of any extension. As long as it has valid Hive commands, it will run that file as a script. Okay, so you can actually put it in a file and you can run Hive-f and redirect the standard out to one file and standard error to another file. All the standard out will be, all the data that is relevant will be going to one file, and all the other irrelevant information will go to other file. So that's the relevance of Hive-f. Here I am not demonstrating, but it is very easy. You just have to create a file and give the commands over there. So the question is, can we write inline queries in Hive and insert into table? So we will get into that. We are not yet talking about creating the tables, inserting data and all those things. You can only do that. You cannot actually, in the latest version they are actually providing insert feature for individual rows also, but that is just a eyewash. You should not use that. You should only use inline queries to load data into Hive. But we will see that in detail later. So this is how you can actually use the Hive-e and Hive-f as part of your data integration tools or data processing tools which you want to develop for the data in Hadoop. So if you understand, you have Scoop, you have Hive. Scoop is used to get the data from source database into Hadoop, and then Hive has to process the data downstream. So these things have to work together. Okay, one way to make them work together is develop shell scripting by integrating these two, and also there are workflow tools to perform to create those dependencies and work in and develop in a streamlined fashion. Those workflow tools are Woozy and also there are other open source tools also like Azkaban from LinkedIn, Airflow from Airbnb, etc. So you have to consider those tools to come up with a robust solution to perform end-to-end data integration and processing framework, starting from getting data from source layer and porting it into the reporting layer. Okay. So anyway, I will reiterate that again and again so that it will go to your mind while designing the solutions later. Coming back to Hive, now if you want to troubleshoot what is happening for the Hive queries. So whatever user you are using to submit the Hive queries, there will be a directory under /temp. Okay. So in my case, I am using my user training 8634. Okay, this is the location my Hive log will be. So if you run Hive as your user, you have to go to /tmp. It's a temp directory in Linux, and there will be a directory with your username if you run the Hive queries, and you will see the Hive log files here. You can go through Hive log and see what is happening as part of your session. Okay, this is how you can actually get the information about the Hive logs. If your Hive queries are failing and if you want to get the details, you can go there. Whatever information that comes there will be emitted as standard out, and you can also redirect to your own file if required. Okay, and then next thing you need to understand, even before getting into Hive actual commands such as create table, data load commands, and SQL, is set command and the parameters in Hive. So in Hive there is a command called set. If you just type set with semicolon, let it launch, then I will hit enter. Okay, this is the command set semicolon and hit enter. It will display all the parameters, and these parameters will come from multiple XML files that are used by Hadoop and Hive as part of this system. So any parameter will be here. So if you want to override the behavior, for example, I have used Hive execution engine. So to get the current value, you can just say Hive execution engine and hit enter. The current one is test. If you want to change it, just change it to what the valid ones. In this case, MR is the other valid one in Hortonworks, and hit enter. Now you will be able to run the queries in MR context. So sometimes you might know a particular word, but you might not know the complete complete parameter. There might be multiple ways to do this, but what I typically do is Hive -e set. Okay, so this set command will get all the results, pipe it and grep. Let's say I want to see the compression. So I can say grep compress. So whatever output which is emitted by this command, which is all the set commands, I am looking for the commands which have the compress in them, and hit enter. So these are the tricks which can improve your productivity quite a bit. You need to understand all these things. Otherwise, you will be overwhelmed about with the number of tools you are facing, and you will be overwhelmed with several aspects. So here you can see there are several parameters with compress. If you want to just enable the compression, you just have to say Hive exec compress output to true, and you have to use the compression algorithm whatever you want to use. By default, here it is using the default compression algorithm. There is no parameter here. We have to override a parameter to actually set custom compression algorithm. in case if you don't want to use default compression after enabling it to true. Okay, so there seems to be question. Let me see that. For certification, no, I don't think they will test all these things. But this course is not just for certification purpose, but many other aspects of it. So you should be able to face the interviews. You should be able to take the questions from the clients for covering all the aspects. I'm talking about all these internal details. Okay, and all these things are even in the certification videos, most of this stuff, because this is very, very important stuff which you need to understand. Just using Hive or Scoop is only 10 to 15% of your entire project development life cycle. Rest of the stuff is 85%. 20 to 30% will be deployment and all those things. Rest of the stuff is using some programming language or tool to develop the data integration framework. That is the major portion of it, not the individual tools such as Hive and Scoop. You have to make them work together, and for that you need to understand all these tricks. Then only you will be able to come up with a solution. Okay, a lot of guys just prepare for Hive and Scoop and think that they know a lot of stuff, and they go to the interviews and they even for the architect level positions, and they fail if the interviewer knows the stuff. So there is another question from Mohan. Are there any tools in market which scans out Hive log and gives out information, or in generic ways give some info queries submitted? No, there is not such tool. There might be some in open source world. But see, if you think about any generalized tool, they will come with a lot of overhead. So now the industry is getting away from enterprise level generalized tools. Yes, programming languages, frameworks are generalized, but the actual tools they want to build in-house. That way, troubleshooting will become easier for them over time. Okay, so in this case, to answer your question, no, there is no such tools which are industry standard. You might be able to grab some code which might be available online and customized for your purposes, but over time the team has to build the competency to take care of such things in quicker fashion, and you have to include all these things as part of your estimates for developing the framework. Okay, you should not overcome it. If your competitor is saying it will be done in two days, you should not say in 1 day without knowing the impact. They might be saying 2 days because they might have tools already to take care of this internally, and they can customize really quick. So you have to see the bigger picture before committing anything to the client. Okay. So now let's get into the Hive. So far we have seen the overall the other aspects of Hive which can be used as part of the development developing the integration framework. Yeah, there is one more important thing. So whatever user you are using to log in, you can create a .hiverc file. Okay, and in the .hiverc file you can actually set the parameters which you want to override for all the queries that are being run by that client. For example, I want to only use MR going forward at this user. So Hive execution engine equal to MR, and also you want to change the location for your Hive log, and you want to give it a different location. If you want to change the location for your Hive log, you can set another parameter, the relevant parameter for that here, and then it will use a different location than temp to generate the Hive log file. Okay, and now once you punch that value in .hiverc, sometimes you want to do it runtime, especially the Hive log. You want to create a different log file for different module. So for example, let's say you created a Hive script And when for a particular use case, whenever you run in that Hive script, you want to create a different log file. So for that, what you can do is, when you do hive -c command, one minute, cancel. Okay, hive -c command, and you don't need to set the execution engine here. You can directly say use training 8634. This also can be can go. No, this cannot go to .hive.rc. You have to use this only. Only the set parameters can go to Hive.rc, and there are some other commands I think can go, or probably this also can go to Hive.rc. I do not remember. Anyway, let me search for my previous hive -c command. Seto va hive-e. So here I don't need to use Hive execution engine anymore. Okay, but as part of your wrapper, you might want to yeah, this is one way to redirect log file. If you want to change the log location, you can also say -hiveconf. Shoot. Hive -e. Okay, so here you can use another parameter called hiveconf, and you can override certain parameters at runtime also. Okay, so these things will come handy while you try to parameterize and run queries using parameter values as part of your application framework. So you have to explore that also. I will not get into too many details to demonstrate that here. So that is another one. Hiveconf is another important one which you need to explore. Okay, now why it is taking so much time? Yeah, now you see it is running in MapReduce context, because in .hive.rc I have set the execution engine to MapReduce. So .hive.rc is the file similar to bash.rc or rc file, which is standard in Linux to set the user settings for the session. So in this case, .hive.rc is for all the Hive sessions which will be launched as this user. Whatever is there in that will override the default parameters. Yeah, very good question. .hive.rc has to be in the home directory. A very, very good question. I did cover that. So you just say cd wherever you are, and run ls-altr command, and .hive.rc is here. And when you actually launch Hive and when you hit up arrow, you will see the history. All that history information will be under .hive history. And if you see, most of the tools follow the similar standard. You can get the Spark history by typing .spark history, by viewing into .spark history, MySQL history, Bash history, etc. Similar is the case with Hive history. Okay. So now let's start Hive and start creating some tables. So I haven't created the course yet on Hive on my website, but the videos are available on YouTube, and on top of that, the code is also available in the GitHub account. GitHub code, sorry, code. I will stop after showing this. We will catch up in the next class. Hadoop, EDW, Cloudera, Hive, and you can see the tables. But if you are using CloudX Lab, I will recommend to go to Hortonworks for now, until I actually come up with the content on the website. It will be done in next 3 days. So you can go to HDP, which is Hortonworks, and here you have Hive directory, and you can look into those scripts. So Hive create databases is to create the databases. Don't create databases with these generic names. Use your user IDs on the lab to create the databases. Hive DDL is to create the tables, etc. So there is example for load, insert, SQL transactions, and there will be much more over time. I will not be covering all these things as part of the class. I will just cover all the important aspects to lay the foundation, and over time you have to practice and review the documentation and build the skills so that you can be ahead of the competition. You have to keep on learning. You cannot put full stop after this course that you know everything about Hive. You have to keep on practicing, you have to keep on learning, you have to keep up to date with the changes that are coming up. And if you write blogs and all, it will help you getting traction for your profile also. By keeping track of a particular tool, if you want, I can also provide a platform where you can write the blogs for this, and I will make sure that you get enough traction if you actually provide the information which is valid for the user base. Okay, so that's it for today. If you have any questions, I will take few questions for next 4 or 5 minutes, and then we will catch up as part of the next class, where Hive will be completed with respect to DDL, loading the data, SQL, etc. Okay. Again, when it comes to SQL, I will only cover few SQL commands, so I will not be getting into too many details, because this is not the course for SQL. If you know SQL, you will be able to learn very fast. Otherwise, you have to learn SQL skills. So Mohan have asked, can Apache Kafka be used for real-time feed into EDW from source systems? Not really. You cannot directly use Kafka. Means partially yes. Means, for example, if you want to get data from weblogs. Okay, so apart from these 3 sources which I have highlighted as part of the earlier presentation, there are other sources also from where you want to get the data from. For example, when you try to buy from Amazon, okay, Amazon only stores the completed transactions in the database. All the other information they cannot actually store. If they start storing, the database will become heavy. But that information has to be analyzed. For example, you go to Amazon, you actually pulled a set of products, and then you decide, you went somewhere and you actually search for the prices, and you decided to discard Amazon basket, and you bought something else. So there is no transaction from your side, but the information which you, the data of what all products you try to buy together is very relevant to understand the buying behavior of the potential buyers. Okay, for that reason, that information has to be analyzed, and we cannot store that information. There will be so many people who will not be completing transactions in Amazon and eBay, and hence they cannot actually store this information in the traditional transactional databases. If they do that, the database will explode, and overall their platform will become unstable. And that was the reason why IRCTC was unstable. Everything used to be stored in database. Now they are using other tools where only the successful transactions go to databases, others will be provided with some other frameworks or tools. Whereas Amazon, from day one, they came up with that design, only the successful transactions will go to the traditional databases. What happens to the other information? We have to capture that information. So if you think about an application implementation, most of the applications are N-tier applications. You will have the client, which is a browser. You will have the application server or web server in the middle. You might have multiple layers of them, and then finally you will have the database where the data is stored physically or persistently, permanently. So all the traffic has to go through the web server. So in web server, typically we use tools like log4j to log the information about errors, exceptions, etc. So what Amazon and other e-commerce platforms have started doing is using the same mechanism of logging. They started logging the additional information which can be used for the analysis for to add value for their companies. So that's where the weblogs are being generated with some important data, some important business data. Okay, and you will not be storing the private information of the customer. I don't need the information of the customer to understand the buying behavior. I just want to understand his order basket which he has cancelled. That can be logged into the log files without without compliance concerns. Okay. To get that data, you have to use tools like Flume or Kafka. So that's where the Kafka comes into picture. So you should have got email. I think you already got the account. So you should have got email from CloudX Lab Venkat. So you have to check back with them whether you have access or not. So Mohan is asking question. For example, when retail store sends transactions in XML feed to middleware, and in turn it sends to Oracle DB as of now, can we use Kafka to receive and send to EDW? Yes. You should avoid querying the database as much as possible. If you have the information in the weblogs, you should consider that over getting the data from the database. Okay, then I have to wrap up because my daughter has some issues with the bus. I have to drop her. Okay, so let me take this question of Gopi, last one. Where does the Hive processed data goes? Will Spark or any other framework uses it? Where will be the analytic logic present? I do not understand the last portion. We will revisit it later. So the processed data has to go back to the HDFS. Okay, so that answers your first part of your question. Data has to be in HDFS. Okay, that being said, I will disconnect because I have to help my daughter. Have a nice one and see you in the next class. Thank you. Bye.